Ram is amazing. Ram Nararamamurthy is the technical executive of EPRI's Electric Power Research Institute. Their decarbonization of buildings and communities division. EPRI supports electric utilities worldwide, and Ram specializes in supporting electrification technologies that provide grid services, low global warming potential refrigerants, and leading edge efficiency. He's been instrumental in advancing California's goals for net zero energy and zero carbon buildings, developing one of the first zero net energy neighborhoods of houses, and developing zero energy affordable housing communities in the Central Valley and in Southern California. Ram, welcome. Thank you so much for sharing what's going behind the scenes, behind the curtain at EPRI, since you guys are just producing amazing new concepts and ideas and testing out new products. Like, ooh, I'm excited for this personally.
Thank you, Sean, and hopefully it'll be fun for everyone. But it's going to be hard to go after Eviday's presentation. That was amazing. That was amazing, right?
Amazing.
That is I
So
learned.
far, it's been pretty consistently amazing. Let's put that
Yes,
out there. Like I think that you're going to do great. If history is proven. I mean, yesterday was amazing. Today it looks like it's going to be amazing. So no worries. Go
Sean.
for it.
Yeah. So yeah, I mean, I'm going. It's a maybe slightly different perspective. I'll start from the top level, kind of go through where there's been so much happening, right, in the last few months, especially the acceleration of decarbonization and where buildings are going is just taking off. It used to be a California thing. It became a California, New York thing. Now it's becoming nationwide. You look at the latest budget allocations from the DOE, they've essentially taken up their FEMP budget to electrify and decarbonize their existing buildings by a factor of 10. They've taken their low-income weatherization program budget by a factor of 3, from like 400 million to like $1 billion a year. So we expect that there's going to be a ton of things happening in the next few years as we all go through this journey together. At the same time, right, you're probably seeing the same headlines that everybody's seeing, right? It's yes, there's electrification, but suddenly there's a lot of companies who are sitting on sidelines, and now you're hearing a lot more about things like hydrogen and other areas, right? So how
Ooh.
I knew I was going to get a roar from Sean, and I will be more than happy to just we can discuss this, okay? But I will tell you, electrification is the most technically feasible pathway today, okay? Um, and part of when I if I think of electrification as a technology, right? When you're working on a product, you're always looking at the competitive analysis, right? So it's important for us to understand how these alternate technologies evolve or will evolve and what it means for customers, because customers ultimately are going to make those choices. So maybe we'll go through this journey. There will always be, I always love being in this conference, Sean, because I can throw out something that might be a little controversial, but we can have a great discussion about it. So we'll go through that, okay? So first thing at the top level, there's lot of configuration of the smart buildings and demand response and flexibility with decarbonization. And one thing I want to kind of lay it out is, there are different drivers that drive building electrification and flexibility. Flexibility is driven by grid decarbonization targets. As the grid tries to, because the value for flexibility comes from what you can do on the grid, whereas the value for building electrification comes from our overall economy-wide electrification goals. So what you'll see is there's a lot of talk about flexibility because, and as we go through this, there are decarbonization targets around the country, everywhere, right? And electric utilities especially have been kind of really driving a lot of their own targets. Maybe it's not fast enough. Now with the national target of 2035, they might have to revise how they do it, but everybody's trying to get to zero carbon. So I'll leave it at that. Maybe we'll touch on it. I will skip it. So part of the research we work on decarbonization, we work on flexibility, we work on scalability, we work on the energy transition, energy burden, right? I'm not going to say we are addressing equity. We just work on the energy burden portion of trying to make this transition equitable. And then finally, resiliency. Let's not forget resiliency, right? What happened in Texas this February? That was an eye opener. And that raised a lot of questions about electrification too. So how do we address that? So first thing, just to set the stage, today it's not just California and New York. It's going everywhere. We might think of places like Georgia as not being in the forefront, but if you look at the targets for the utility is trying to get to 100% zero carbon by 2050, 80% reduction by 2040. There are targets in the city of Atlanta. There are a bunch of other cities that are also setting their own targets. So together, right, together, this transformation can happen regardless of what the federal goals are, right? Corporations are setting their own targets. So between the corporations, the cities, and the utilities, this decarbonization movement is happening. It's going to happen. It's going to accelerate. The goal is, how do we scale this? Again, as we mentioned, right, the city and utility targets, they complement the state targets. But everybody's looking to California and New York. We work nationwide, we work worldwide, right, with energy companies. And the biggest question I get is, hey, what is happening in California with all these all-electric building codes? How is that going to affect us? How do we adopt what you're doing in California with affordable housing? How do we adopt that in our area? And it's not just the US. I get the same question whether people from Ireland or people from Spain or people from Italy. Everybody's looking at, hey, what is California doing, right? And so, in a sense, we have a responsibility to show the way, but also understand that it is not just us. There's a whole world that's willing to take this burden, share the burden, and scale the market transformation. So this is one of my favorite slides. I throw it out, and people can interpret it different ways. Any new technology, and I've been in startups, right? A product, for it to scale, everybody's excited about the concept of the product first. And then as you try to actually build the product and put it in actual buildings or in the field or wherever, right? When you try to apply it, you run into all these barriers. And then you run into barriers of customer adoption, right? So what happens is any new product or technology goes through the cycle. There's this innovation, everybody gets excited, everybody has high expectations for it. And when it doesn't perform to those high expectations, goes through a steep cliff. Some products are able to power through the trough of disillusionment, right? And our goal is to make sure that we can actually power electrification through the trough of disillusionment. And how does the disillusionment happen? It can happen because it's too expensive. It can happen because customers are not happy with what they end up getting when we go through this. How do we get through that, right? And that is our challenge. Our challenge is not just saying, hey, we can electrify. We know we can electrify. How do we get through the trough of disillusionment so that we don't get stuck there at the bottom with electrification? So we know it's the most feasible technology today. How do we get through it? I always think of this target, solar scale, when we had $1 per kilowatt target. Can we set ourselves a target to electrify, decarbonize our existing buildings at $1 per square foot? If we can do that, it's going to happen. Customers are going to adopt it. It's going to happen. But how do we get there, right? And it requires all of us working together to do that. So I like to talk about this concept of hybrid decarbonization pathways. We know that in many cases, right, electrification can be expensive. I'm going through the same thing, right? Electrification of my existing home is expensive. But you're going to have some people who are going to take it and say, we are going to do it. And they're going to do this early electrification strategy. But most customers are going to say, hey, what can I do today? What makes sense for me economically to do today, right? It is very important that we do what we can today to drive down their energy costs, drive down their energy burden, but keep the options open so that they can do the adaptations later, whether that's in 2030, 2035, etc. I think of it as like cycles, right? If somebody changes their water heater today, that's not going to get changed out for another 20 years. Well, not 20 years, 12 years. If somebody changes out their furnace today, that's another great example, right? If somebody changes out and does a like-for-like replacement of their furnace today, that furnace is going to sit there for another 15 years. So how do we do what we can today? Let's not make perfect the enemy of good. Let's do what we can. Let's try to get our carbon content in our existing buildings down by 50, 60, 70%. We can do that today without aiming for the perfect, and then give ourselves some time so that we can get technology solutions or incentives or application solutions so that we can get to the 100%. And again, why do we talk about hybrid pathways? And I am ready for all the brick paths. Sean, you can throw them. Okay. But I think about it from first cost neutrality. How do we get there, right? How do you avoid things like panel upgrades? Because those are huge barriers to electrification. How do we provide resilience? And we are looking at some very different concepts of providing resilience. Can we provide resilience? Can it be provided cost effectively with a single fuel solution in our buildings? How do we drive down operational costs, right? Especially in California, IOU territories, the operational cost has a high risk in on the electrification side. And finally, how do we manage grid impacts? Many of the times when we work in affordable housing, especially multifamily housing, it turns out that the distribution grid's not ready for electrification. So how do we do that, right? So we think about the roadmaps. What are the things we have to do so that we can decarbonize our building stock? So first thing, reducing first cost of installation. And and I love Sean's guides, right? Retrofits, electrification retrofits, the technologies he's putting there. How do we make those into packages that can be scaled? I think there are some very innovative programs coming in from the state, like the Build program, the Tech program, and so can we get packages that make it more feasible, easy to retrofit existing buildings? How do you reduce customer energy burden? This is a more challenging question because of the way our electric and gas rates are. How do we do this, right? Do we do redesign of rates? How do we do financing programs, on-bill financing, so that electrification can actually be rolled into it? And then on the other side, the value equation, enhancing customer benefits. And finally, I think there's work to be done both on the National Electric Code, NFPA 70, as well as trying to really think about how we do our distribution planning on the grid. Does adding electric load automatically mean that we are going to have to scale up our grid? How do we have to replace our wiring? Do we have to retrench our wiring? Do we have to replace transformers, right? Can we do something about that? So these are like the different buckets under which we are exploring different ways to be able to reduce both the first cost and the operational cost of electrification. And finally, we have this concept of what we call affordability sequencing. As a customer, right? When I think of myself as a customer, I cannot buy an EV, put solar on my roof, and put in a heat pump at the same time. I just cannot afford it. So customers are going to make choices based on what they can do at that time, what makes economic sense. And we have to recognize that, because that goes back to our pathways to electrification, pathways to decarbonization. You have to understand how you're going to make those choices and how those choices are going to help us decarbonize. Um, Sean, shall I just keep going, or do you have any questions?
Well, I want to agree with you on a practical level, even though I was an expert in electrification, right? That didn't actually finish the job until 2017, and that was triggered by both an explosive gas leak in my front yard and my mother-in-law dying in the Tubbs fire, all within the space of a couple of months. And I was like, okay, today is the day we're absolutely stopping. There's nothing that stops us. We'll go into some debt today and we'll get this done. And we're completely done. It was an emotional decision that was not as practical as the one that you were laying out. And I mean, I'm glad you're pointing out this, because there is get it all done at once if you have millionaires with financing working on apartment buildings. And so I'm just, in my mind, I'm agreeing with what you're saying. Um, and oh, and I think that this is fun. Kurt Hurley, he commented back on your, like, hey, everyone's talking about what California is doing. And he said, well, regrettably, many state legislatures have passed laws to block building electrification municipal reach codes. And my response, and I want to hear what you're going to say. I can say quickly, Kurt, I think the laws blocking gas bans are the best advertising possible for the idea itself. The action made global news, the reaction made even more news, and now everyone is talking about electrification. And I don't fear the reaction to leadership, in other words, that's inevitable, and people follow leadership. So what do you think of the gas bans? Have they changed people's mind in your conversations in Spain and Ireland and such? Or they're like, oh, look what Oklahoma's doing. They're banning gas bans. Like, I'm curious how that also plays in.
So, it's a very good question, Sean, because when I work with a utility like, say, Salt River Project, right? They're an electric only utility, and they're like, hey, we know how to make electrification work for our customers. But unfortunately, the ban on gas bans is now standing in their way of electrifying their building stock, right? They had all the communications ready to go. So it's going to be one of those things where it's going to take some, I agree with you, but I think it's going to take some time to turn it over because legislation, it's hard to overturn legislation. State of Washington is fighting this right now, right? Like they've had a legislative ban on fuel switching for many years. And now they're realizing that people like Seattle City Light, right? Their power is 100% hydro. They're already zero carbon electric. And the way to decarbonize is just to electrify. But it takes time to overturn that. Like people are realizing that, hey, we now have to do electrification. We have to get rid of this legislative ban on gas, on fuel switching. But it takes time. So I think we are right now on the front end where it is means that some of these states, it's going to actually slow down electrification. But I think it is going to turn over in a few years when it turns out that, hey, maybe the rest of the country, maybe the rest of the world's going that way. Now, I will say that in Europe, it's a different situation because in UK, for example, they said they were going to electrify everything in 2010, and it turned out to be too expensive. So they said, yeah, electrification is not the way to go to decarbonize. So they're now putting a lot of money into hydrogen. So that's really, I think, what we'll have to make sure we don't get into. We have to make sure that, hey, we address those technical and economic concerns, because then people will realize that, hey, it's actually the cheaper and better thing to do.
Thank you. Okay, you should
Long-winded
continue on.
answer. I know I got only 9 minutes, so I'm going to skip through some of these. This is just some learnings from our field work. We just finished a big project on affordable housing retrofits, where we went all in trying to do electrification and energy efficiency. And interestingly enough, you can actually see the biggest impact of electrification by looking at the gas bills, right? So what it turned out was that one of the communities we worked in Ontario and Southern California, we were able to reduce the carbon content of that 80 home community by 40% by doing efficiency and electrification. Efficiency, and this is something very important because right now we are struggling with this from customer programs perspective. Some of the best measures we saw were things like putting in foam insulation under the roof. That way you replace a roof with a cool roof and you put in foam insulation under it. Really kind of reduces your heat load, makes electrification a lot more cost effective. Um, Getting insulation into the walls, that's another big one, right? Replacing windows and patio doors gave customers a lot of benefit because it made their indoor environment much cleaner. They don't see the dirt ring around their windows anymore. And we couldn't electrify the water heating because it's just going to be too expensive, because of distribution system upgrades. But having said all that, right, we still saw a significant, like 70% reduction in gas usage. And more importantly, even switching the cost of electric heating from the property owner to the tenants in this case, because the property owner pays for gas, tenants pay for electric. We were able to reduce the overall bills down by doing the deep envelope retrofits. Trying to replicate it, we are really struggling because many utility programs today, or even other programs, we don't have good envelope retrofit incentives. So that's something that I would really try to push on, that we increase our weatherization incentives. Post retrofit tenant surveys, this was actually very good because what it showed was that going from gas to electric heating, most of the customers actually thought, 78% of customers thought that their heating system worked better after we switched to heat pumps. Same thing on the water heating. But in this case, we didn't switch to electric, but we did put in a tankless. Again, they saw a pretty big improvement in their water heating too. Can you hear me okay?
Yeah, no, you're coming through perfectly. Yep.
Okay, perfect. Yeah, I just saw a little blurb saying my internet might be unstable. So I'll try to quickly go through key electrification challenges. I won't go through it again, but we'll have to address. This is a really important graph because what it shows that is that in California, we save more carbon even today in our buildings by electrifying our heating systems, heat pumps and heat pump water heaters, than from putting solar on our roofs, than from putting solar in storage. But from a customer's perspective, the customer saves a ton of money putting solar in storage, and they actually might end up losing money by electrifying their heating systems because of the way our rates are, because of the way net energy metering works. We need to figure this conundrum out so that we have incentives like net energy metering on the electrification side, because otherwise the numbers just go upside down. And in fact, you can see it between Sacramento and San Francisco. There's a huge gap in terms of the economics of electrification. We got to figure this out, right? So that's one of our big challenges right now. Yeah, let's skip through this. Just want to kind of emphasize one of the areas we are working on is 120 volt heat pumps, heat pump water heaters, trying to figure out if that can help us reduce the cost of electrification. I'll touch briefly on this. It's not just a California problem. We are also working with other utilities over in the cold climates, and they're all looking at hybrid heat pump solutions. In fact, many of the Midwestern areas, they're looking at gas-fired heat pumps and maybe even switching them over to like hydrogen-fired heat pumps or something. So there's still a challenge to be addressed in terms of cold climate performance at this point. Commercial building, we are working on a hospital in San Diego, and it turned out that most of a big portion of the gas usage was in the hot water reheat loops. The reheat loops that work in the HVAC system to temper your air temperature, they're actually using a large portion of the hot water for heating and cooling. And so we are working with a new technology by which we can actually eliminate the gas-fired boiler for reheat and replace them with a heat pump by substantially reducing the amount of reheat that's required. So it's not just residential, but there are really interesting technologies in commercial too. And finally, this is something that's of high interest to us, manufactured homes. It's usually the forgotten sector. Manufactured homes don't fall under Title 24, which means they are not subject to the energy code. In California, they're subject to the HUD code. So we are working on trying to figure out how to get to net zero all electric manufactured homes. The other interesting part, manufactured homes have the same power limitation, 100 amps or 50 amp power limitation as existing apartments and affordable housing. So we are using that as also a way to see if we can address the whole electric infrastructure issue. Oh, and one more thing I want to mention is another area we are working on in this is looking at reducing fire spread so that these manufactured homes can also be more fire resilient. And finally, I know Kurt is on the line, so we are working with Kurt, looking at how can we do electrification with resilience. So we are looking at building design architectures, electrical design architectures that can help enhance resilience in multifamily buildings. Because today, if you put a big battery, like the way most VNEM and multifamily buildings work, if you're putting in a solar plus storage systems, they're all connected to the common area. So when the power goes out, people who live in the apartments don't have power. That's just the way the electrical wiring is set up in most multifamily buildings today. So even though the batteries might be going in with SGIP incentives for resilience, we really don't get the level of customer resilience that we would like to see. So we're looking at new architectures, electrical design architectures to do that. This is a little bit more controversial, but maybe not. We look at it as waves of decarbonization. So right now we are in the EV wave, the building wave is coming next. And then ultimately we have to get to industry and agriculture. How do we address cement and steel? How do we decarbonize those, right? And that goes back to the previous presentation, because those decarbonizing the raw materials that go into buildings, that's going to actually take more work. That's going to be harder than even decarbonizing our building energy use. I'll skip through this. The biggest thing is this, and this is going to be, when we did a back of the envelope calculation, it turns out that if we can get our grid ready for electrification, that can substantially drive down the cost of building electrification. So we really have to figure out how to get our grid and our homes and buildings ready for electrification. So when somebody's water heater goes out, they can make that quick switch to a heat pump water heater without having to worry about panel upgrades, etc. Without that, the cost of building electrification could be quite high and could be a deterrent to customer adoption. You'll see in the graph that RNG and biogas might have low cost, but the problem there is supply. And we're just probably not going to have enough supply to be able to supply the all our homes and buildings with RNG. So building electrification still remains the most cost-effective way longer term. But if we don't solve the infrastructure issue, we will have other alternate technologies like hydrogen competing with electrification in buildings.
Hey,
And I won't. Yes,
take
I'm
take your
done.
time. No, don't. It's okay.
Yeah.
Don't be done. Go back to your last slide. Kelvis from he's zooming in from Kenya, and he is not here yet. So I think that you should take some questions and just like go
Sure.
through the last couple slides, take a little more time. And
Yep.
I, I want to I want to ask you about like how your work is going on small heat pump water heaters. And Michael Winter wants to talk about the low efficiency of hydrogen. So take the 15
Okay.
minutes here because we got it.
No problem. I'll be happy to jump in. My last slide. This is just my personal journey. Um, I'm not sure I'm doing the right thing by getting a solar and storage system because I think part of the reason I am challenged with rooftop solar is that as a grid gets cleaner, the carbon benefits of rooftop solar essentially dwindle out. But I'm getting storage mainly because I feel like, hey, it's going to help me with TOU rates so that I can be electrification ready. Right? I'm working on my heat pump mostly because we need air conditioning now, and that's going to be a big trend. Pacific Northwest is already seeing it. Um, I'm working on my panel upgrade and insulation and trying to do all of that together with my solar and storage and my EV chargers. But I am very interested in maybe putting in a 110 volt heat pump with gas backup. Keep my existing water heater, but put in a 110 volt heat pump water heater and see if we can do that. That's not sorry, that's for the water heating. And interesting enough, I just opted out of my CCA, went back to being a PG&E customer, and that's a different journey. I love working with CCAs. I think they can do great things. But I think one of the biggest benefits of being a CCA customer is having innovative customer programs. And I think I would love to see more innovative customer programs coming in from the CCAs, especially if they are outside of the regulatory context. So that's just like my personal zero carbon journey at this point. And with that, I'll be happy to take questions. Let me jump into the chat, Sean. Is that okay? Or do
Oh,
you want to
please
read that
do.
first?
Yeah, no, I think Martin Volker was hoping you'd go back to your previous slide and just speak to it a little bit more, if you before you take questions, just to. So
Sure.
his comment was your last slide matrix is missing context. So apparently, more context.
Yeah. So what I was trying to see here was, Europe is really going heavier on hydrogen, piping hydrogen to homes or hydrogen blends to homes.
Hmm.
And yeah. And so I was looking at, okay, if we go back to go out to 2045, what do we see our homes and buildings looking like, right? Are we going to be piping hydrogen or some zero carbon fuel through our existing gas pipelines? Or are we going to be all electric to get to that zero carbon? And so that is a question I think we have to answer. Electrification, I think, is still the most feasible way, but there's a lot of money being put into hydrogen. Um, yeah, Europe is just sinking a ton of money. I know it's in the CEC's EPIC 4 plans to look at hydrogen as an option. So that is a context under which I was looking at this. And again, this is very rough because there's so many unknowns with non-electrification options for getting there. The assumption here was that, hey, we could get green hydrogen, right? Green hydrogen all out of renewables for about 3 times the existing cost of natural gas. Now, I think the latest numbers are that green hydrogen at best would be 5 times the cost of natural gas. And to start with is going to be around 20 times the cost of natural gas. At 5 times the cost of natural gas, I think electrification, even with today's rates, right, turns out to be more cost effective, right? So, but that's the thing. We don't know what innovations are going to happen in that low carbon fuel space in the next 10 years with the amount of money that's being put in by Europe, Japan, and other countries. Okay. And even the DOE, right? DOE is going to be putting a lot of money to hydrogen because I think one thing that's happened with hydrogen is I think on the transportation side, it's kind of becoming apparent that that's not going to be the solution. Maybe for some very heavy duty or off road, right? Um,
Airplanes.
yeah,
Airplanes seem to be one place where
yeah,
like there's
airplanes.
a
Yeah,
competition right now between battery-powered airplanes and hydrogen-powered
right,
airplanes.
exactly.
Yeah.
Or marine, right? There's also like I think the DOE gave 7 million to Golden Gate ferries in San Francisco to test hydrogen, right? So, um, but again, that's the thing, we don't know, and that's the beauty of technology, right? Pathways, you got to be ready for different pathways. But the pathway we know today, which is electrification, we really have to work on getting the cost down for existing buildings. If we do that, then it becomes a no-brainer. And that's what I would say. Let's work
Yeah.
on that. Let's really
Well,
work on that.
okay. So the question, and there's a bunch over here, but the one I really want to get to first, I'm the host, is I want to know
Yeah.
what cool things are you doing at EPRI to lower the cost of water heating? Like I know you guys have the new light, right? Can you speak a little bit to the small package Chinese heat pump that attaches to the wall? What you got?
So it's interesting. I have units sitting in my garage that EPRI developed in 1987. These
What?
are like this is like a little package, right? It's like 1 feet by 1 feet by 1 feet. Okay, heat pump add-on that goes on top of an existing gas water heater in low-income communities. 1987. So apparently, First Energy in Ohio had 100 of these sitting around, and they shipped me four. Okay, so it's sitting in my garage. If this was a live conference, I'd have brought it in. It looks like a bucket. Okay, and the funny part is this: we still don't have that product. That product would be perfect. Okay,
Right?
it's
Yeah.
but and that's what we need to work on. We really need the small form factor products,
Mhm.
the new lights. Um, the work we have done shows that, like for example, the new light, right, came in from China. We tested it in Southern California. Works well. It can actually provide the performance. It's 1500 watts. It's a 240. That's fine, but because that's their native, right? Because
Yeah.
everywhere around the
Right.
world, it's a,
Voltage can be changed. Yeah.
yeah, that can be changed, but it provides the performance we need. Okay, so I think the products are there. We just need a little bit more data, whether the smaller 110-volt units um, can actually provide the hot water service that we need for maybe 98% of customers. Okay, if we
I
can
have
hit
one
that,
here, just like
yes,
you sent me over
yeah,
theirs, which I'm very appreciative of, and it's worked out terrific. I keep it at
perfect,
132 Fahrenheit, and it can fill like an old-fashioned 50, 60-foot gallon steel claw tub
yeah,
bathtub. It's totally awesome, and it plugged in with an extension cord because we didn't like, and the guy wasn't prepared, so it's like it
yeah,
did everything. It worked. It was fast to retrofit. It provides all the big loads that we need. I stored at a slightly hotter temperature. Things are great.
yeah, perfect, Sean. That's what we need, right? That's
Mm,
what we need. Because if we can get that and we can roll it out through multifamily programs, it'll get adopted in single family. Okay, but
mhm.
if you can roll it out at scale through programs, right, manufacturers get the volume and it
Yeah.
works. um, my personal thing is like I feel like we spend a lot of time on flexibility. When you get to a 110-volt unit, you don't have much flexibility at all. So I think we
Yeah.
shouldn't be worrying about flexibility or demand response or anything from water heaters. Let's just focus on getting these 110-volt units into every home.
100% agreed. Our field study of 22 tanks showed that if we kept it in heat pump only mode, which would be appropriate, don't need
Yeah,
the resistance, which is the high voltage, that we met all the demands in 99% of the households. Like it was, we had fantastic performance. If we just didn't use it in a flexible way, if we just ran it
yeah,
full blast at 400
yeah,
watts, not 4,000 watts, that was the big move, was just run it at a tiny amount.
yeah.
So
Just
I should be fair
straight
to
out,
other
right?
people.
Run it straight out. Just say that there's no flexibility from heat pump water heaters. Let's forget the flexibility piece from heat pump water heaters.
Yeah.
And then I think that'll actually take the money from flexibility and put it into actually electrification, and we'll get it.
Agreed.
Um,
We'll have to strangle Pierre, unfortunately, to get through him. But I'm willing to argue. So to be fair to other folks here,
yes.
Ted asked the first question. He says, Ram, can you comment on the impacts of proposed NEM 3.0 rules, which is the price that's paid for solar electricity, rooftop solar in California? For those who don't know what NEM 3.0, it's the price that's paid for rooftop solar. So the proposed NEM 3.0 rules that you've seen on impacts to heat pump water heaters, electrification generally, and issues of self-utilization of solar versus new retail rate of electricity export to grid in the equation. So what are your thoughts on NEM 3.0?
Okay, so I have to apologize that I haven't really dived into NN 3.0 very much, but my I will just give you my impression. I think if we go back to where a lot of our grid costs are, they are in the transmission and distribution networks right now. Our commodity costs are pretty low. So if we have to decarbonize, right, we got to figure out how to it's to electrify. We got to figure out how to appropriately cost out our transmission distribution networks, because I think that will drive new technologies like smart panels and demand limiting and electrification. So that's my thought on that area, right? Um, I I haven't dived into the details. I just at this point we've been looking at it more from the carbon perspective and the carbon impacts. If we go to a carbon based pricing, the carbon impact of solar keeps diminishing as a grid gets cleaner.
Hmm. So fair enough, fair enough. And so I mean his issues are more at the pricing, the depricing of it. And your point is so well made that it's really the heat pumps. That slide blew my mind. You said this is an important slide. It's like, whoa, is that an important slide? Showing the disproportionate benefits of decarbonization with heat pumps versus solar and batteries, and yet the inversion of the price signals that we're getting from the
Yeah.
market. Um, so then there's a whole bunch of comments here. People would like you to expand on your thinking on CCAs versus PG&E, which you as a utility consultant, I realize it's a little fraught territory. So you're welcome to answer in whatever way you feel is
Oh, I have to tell you this. I love the CCAs. I love working with all my friends in SVC and Sonoma Clean Power and others, right? The reason I made the switch back is that unfortunately I didn't find great customer programs with my CCA, and because of the PCIA charges, my CCA bills were higher than a straight PG&E bill. So I just felt like, hey, if I'm not getting customer program benefits, I mean, as well stay at PG&E. But I love working with CCAs. I think they have great capability for innovation, and we are working with many of them in many of our projects. I made a choice as a customer because for me, all of this is part of my research. It's for me. I want to live my research, right? I want to live how we make decisions. I'm really interested in how customers make decisions, right? And I want to make the same decisions customers would make. So that's really why I did that, right? But I think CCAs, I think they have such a great capacity to innovate, and I think they are the future.
I'll note here that we had an early CCA, or we actually get calls all the time for Redwood Coast Energy
Yeah,
Authority. We're supposed to Redwood Energy. And I too have been disappointed. They led early on some of the least expensive things because PG&E, I think, forced them to have a high payback. So they did light bulb replacements, and they've done some transportation, but it's 2021 and we still don't have electrification rebates
yeah,
on them. And I feel like the innovation they did is that PG&E refused to decarbonize its energy resources. We went through that I was actively selling green energy in 2000 during the energy crisis and got to see how hostile PG&E was to any solar at any point in its grid. Like just and CCAs were this solution to force renewable energy into the grid. And PG&E has had its ass handed to it since it's gone through bankruptcy, and also there's a ton of laws that just force it to change. Period. But it felt like CCAs had a really important social environmental function, and they're not keeping up with the next wave of important function they need to,
yeah,
exhibit for local democracy purposes and such. They just got very small in the things that they're taking a whack at. Many of them, not all, because Silicon Valley Clean Energy,
yeah.
TCE, they're amazing leadership groups. So some with Clean Power, but okay, tons of people are trying to ask you stuff. So just to be fair to them. Um, and Michael Winkler wanted to tell me, yes, Redwood Coast Energy Authority now does have rebates for heat pumps. My bad. That's true. They just came out with those. My bad. Um, Rom, I think Tom wanted to say, Tom Cabot says, Rom, most CCAs don't block your access to PG&E programs, and they provide a small rate advantage, and they have more aggressive low carbon procurement policies. So there is still a counter to leadership there.
So the way what I'll say is this, right?
Hmm.
And again, maybe I need to understand better about the procurement policies. But the base CCA thing I have is like a 50% green, and the Cal ISO grid is about similar because it's not PG&E who controls the carbon on the grid anymore. It's the ISO, right? So if
Hmm.
you look at the ISO's energy production, right, it's pretty much already there.
So then, let's see, Jim Lutz, he's pointing at that Geyser, the C8 series. I have talked with Nile, which produces the
Yep.
Geyser. So can you make any statements? I'm on an NDA with them, but I can just say that at the minimum, we're not getting to see one in continental United States anytime soon. That's just not, they're not doing that, which is why I'm like pushing you, like, tell me about the new light. Are they going to come? Because we need some really good retrofit products. Um, we, let's see here. So Jim is saying it's coming soon. Are you lying? Or are you truthful, Jim?
I've been waiting for it since I saw it at SMUD a year and a half ago,
Yeah.
just before the pandemic. So I don't know where they are. Again, yeah, I
Well,
haven't.
and I do, but can't say. But
Okay.
so I can only make the briefest of like, I don't think it's coming soon to the continental United States. I think they'll be trying it out elsewhere.
Yeah, I think we are doing a project with Ariston in SE as a standalone, like a add-on hybrid heat pump water heater system, and of course,
Yeah.
we're looking at some field deployments with the Ariston units, and of course, we tested the new light and a couple of other products from China in the lab in Fontana.
No, Ariston, they sent over their product as well. So I have their 30
Yeah,
gallon tank
yeah,
installed, hanging on a wall,
yeah,
and it's working out terrifically. I have
yeah.
a tenant who will I have asked them to take the longest shower you can handle being in a shower. They're like, well, it's 35 minutes and I'm really bored. So I'm getting out now. And there's still plenty of hot water. So apparently it's capacity and all the rest of it's doing
Yeah.
fine. It's low flow shower head, but it's a nice low flow shower head. Um, so it does.
And by the way, low flow shower heads are super important. I know the DOE almost outlawed them or changed the whole water thing, right? But those are going to be super critical for us to be able to electrify water heating.
Agreed. Um, so let's see, Emily. But my understanding is that Ariston HTP are not bringing something new soon, and that is so new. Like, can you give us any like, will we get those cool wall hung heat pump water heaters? You think?
So you know what, Sean, I have to apologize because we really haven't followed up with them after we did the testing
Oh,
because of
okay.
COVID. Because that testing happened in Southern California last year, and I think one of the things I should do personally, I have unfortunately disconnected a little bit from the 110-volt side because I've been focused on the central heat pump water heaters more. But I need to come back and join you and Jim and Peter and the whole AWHI gang on the 110 side and figure out what we can do to advance it. So
Yeah, I would really appreciate that. I have a certain feeling of desperation after all these years and
good.
so many quality
Okay.
needs and so much need and it being such a huge obstacle. Because I mean, one of the things you said radically at the beginning was $1 per square foot. And I started thinking about, well, that's $1,200 for a 12,000 square foot home, and that's $2,000 for a 2,000 square foot home. Like, oh wow, that would be hard with the current pricing of things, and particularly with people's standards. I mean, if we could do 120-volt stoves, then that we're good. I mean, like I can see how to do that pricing, or the portable heat pumps that are $600 for like an inverter controlled, super awesome portable heat pump. $600 that'll do a
Yeah.
ton. That'll do a house. Like I can see a pathway for each of those products. A small cheap water heater, small cheap portable heat pump. Water heaters are the ones that have to be installed professionally. That's the one tricky thing. You just can't get around that.
Yeah.
So there's labor that you have to pay for that's harder. Uh, Jim Lutz says, Nile has signed up their AWHI 120 volt field trial. They're signed up for the field trial. The field trial starts later this summer. Not sure Nile will be in at the start of the trial, though. Oh, okay. Well, at least they're playing around. That's good. Tom Cabot says, we know at $1 square foot that we have to avoid the panel upsize and we don't incur utility distribution upsizing rate impacts. And I think that ties back into an earlier comment where Tor Allen said being infrastructure ready would be easier if one could electrify within the confines of a 100 amp service. What work is being done at EPRI on this aspect of electrification?
Okay, so that walks right into here. And Sean, you're involved in this too, right? We've been working on this a lot. So
For you.
um, so here's this is a project that we are working on with manufactured homes. And in an interesting way, this is of course new construction, but it gives us a almost like a clean sheet of paper design opportunity for the 100 amp solution. And because most manufactured homes, even though they're newly constructed, they have to go into sites that only have 50 or 100 amps. 50 is Sean's reach goal. We'll get there. Okay, we'll get there someday,
There
right?
are 50 amp services around me physically. I see them, like they're real.
So, but let's at least try to get 100 amps, right?
Yep.
So the way we are approaching 100 amps is we are actually building 3 different homes in 3 different ways to see how it works with different 100 amp architectures. Um, the first one, of course, you have to have good insulation to be able to drive down your HVAC load, drive down your tonnage, which drives down your breaker size. But what we are doing in a couple of these homes is putting in smart panels. In this case, we are using a product called Genius by Coben. Um, and the reason that we are doing that is because that can do demand limiting. So I can do a software demand limit and see how I can switch circuits to be able to control it within 100 amps. So we're putting in demand limiting panels with 240-volt equipment.
Oh,
And then another home, we are doing 120-volt equipment, right, with standard panels. So we are looking at these multiple pathways. We are so again, cooktops, 30 amp, 240 cooktops, to the extent possible, 110-volt heat pumps and heat pump water heaters. So we are using the Innova Focus along with the 110-volt heat pump water heaters. That substantially drives down the panel requirement. Um, and uh, and then what else? The cooktops, yeah, the dryers. We are using the Miele 120-volt dryers, heat pump dryers. So we think we can get there with the 100 amp. Okay, and that's the thing, these products are right at the cusp. If we can create a architecture for a home taking the 4 big loads, right, water heating, space heating, cooking, and drying, and we can show that we can get to 100 amp limit, I think that really opens the door for everything, right? Avoids
yeah.
panel upgrades, avoids distribution upgrades, substantially reduces the cost of electrification. So we are trying different pathways to see how we can get to the 100 amp limit.
My opinion is that the stove is the last of the domains that we haven't mastered yet, investing in efficiency. Like we don't have efficient pots, we don't have insulated ovens, we don't really have higher quality 120-volt devices. We only have low quality 120-volt. Well, that's not true. We have commercial single burners, but they don't have any oven. They don't have like, we haven't made a really good retrofit ready oven. Like no one has, except maybe in Japan. You see these small ovens with a 3 burner on top, but I don't know anything about these things, or their voltage or their power. I just know I've seen them. I know they exist, that they sell them commonly. They have a very 3 induction range tiny drawer oven thing, and I assume that's low power. But
Yeah.
yeah, I think, you know, Steve Leffler, he started building 50 amp trailer homes, but they're only about 175 square feet because his restriction then was the plug loads that's required of every square foot. It was the big challenge. Like you could only make a house so big before you started running into 60 amps and 70 amp needs. So that was, I found also the other restriction is that the plug load circuits are all assuming incandescent lights. So they have really high allowances of wattage per square foot that don't match our current lights, because they're all like lighting circuits
Yeah.
basically that allow plugs also. Um, so just responding, I see some places that I think we can do 50 amps. We just can't do a very big house. Or do your load switching. So if someone here wanted to say like, hey, what is that panel? Josie, was asking, what's the name of the smart panel? Is it the Genius? What one are
It's
you?
called Genius, Koben, Koben. They're out of Ontario, Canada.
Uh-huh.
Um, and so we actually looked at 6 different products for smart panels, and we chose this one because it also has the capability to connect your thermostats through APIs, and that way you can have a little bit more smarter energy management, not just like an on-off control. So that's what we did.
I'm right now. When I have resiliency conversations with designers. I'm like on a design conversation pretty much every day with some different apartment complex, and so I feel the news literally affect conversations in a very like, oh, what just happened? People are seeing the deaths that are coming out of heat waves, and it's changing their
Yeah.
mind about what the smart panels should be turning off. Now we're starting to say like, well, people aren't starving. We can leave the refrigerator off. Like we thought, oh, we're going to make their food not spoil. That's important, right? Now it's like, well, maybe we should keep their air conditioner on, or maybe we should at minimum keep a ceiling fan on, a powerful ceiling fan. Like we have to do something to keep
Mhm.
people cool when their electricity's off in the summer, because they're going to die, and
Yeah.
they're not starving to death. Yeah.
And the cooling discussion, right? It's like we haven't had much of that on the West Coast because we've not been subjected to these before.
Mm.
But having grown up in India, right? I mean, RMI has this great effort called the Global Cooling Challenge.
Mm-hmm.
And if you look at it, 4 of the companies shortlisted are from India
Mm-hmm.
because cooling is such a big issue over there.
Yeah.
And they're looking at really innovative, low carbon cooling solutions. And that's something to keep track of as we get more heat waves. I would really kind of, I think that's something that's not just for third world or
No,
other countries, right? It's
go
for
back
us.
to our grid. If we were
Yeah.
to go around and put in high performance heat pumps, which is by
Yeah.
definition a high performance air conditioner, you get like a SEER 19,
Yeah.
SEER 24, something like that air conditioner. We could cut our AC loads in half, like now, which we could really use, like now.
But one thing I'll warn Sean is that the higher efficiency air conditioners, the variable speed ones,
Hmm.
they will actually use more energy than lower SEER air conditioners at peak loads, at peaks. And the
Why?
reason is this, because they can actually ramp up. If it's a
Right.
5-ton system, they can actually ramp up, over ramp, and they
Right.
have the ability to keep the cooling going even when it's 110 outside. Whereas these single speed ones essentially kind of cut off. They're like, okay, we are maxed out, we are capped out, right? So going to a high efficiency air conditioner is not a solution for peak load management.
Oh, okay. What about restrictors? I mean, this idea that people are guaranteed even more air conditioning than the product is rated for
Yes.
obviously is a bad idea. We just
Yes.
want
So
it
it's
to work.
actually going to drive up your peak loads if you go to very high efficiency air conditioning.
But they are programmable. Like inherently, these devices are have a computer in them, and frequently they are grid controllable. So it seems to me like we could still have a high efficiency air conditioner. Just don't give it the appropriate signals, either programming or signals from the grid, so that it doesn't
Yeah.
do that. Like I'm really hot. I need to cool off, so I'm going to just ramp it up all the. I mean, yes, you understand.
So I think what we have found to be most effective is actually pre-cooling. So using your smart thermostats to pre-cool, we
Mhm.
saw some very good, even in like Nebraska, right? We found that with pre-cooling, your air conditioner, your smart thermostat gives you 2.8 kilowatt hours of energy storage capability. That's equivalent to $5,000 of a battery.
Okay, so the pre-cooling where you use the whole house as a battery is the cost-effective way, and
Yeah.
storing the energy in a chemical bath called a battery, electric battery, and then re-releasing the electricity, not the cost-effective way. I'm not surprised.
No,
I think that
we
most
have data. We have data from hundreds of homes. We did statistical analysis of
uh,
pre-cool, um,
pre-cooling.
and it works.
And it makes sense because you can use decarbonized daytime electricity
Yeah,
when the air conditioning needs
exactly.
to be peaking, and you should pre-cool for the evening. And just, yeah, don't turn the AC on when you come home. Turn it on at 2 in the
Exactly.
afternoon.
You can
With a,
make it adaptive, like the Nest and the Ecobees, right? They can know when you're coming back. It can be highly adaptive. You can drive your home down to 68 with all the solar power you can get, and then take it off to 72, 76, 78. I know I got it. I think it's 11:30. So I'm sorry for talking through the next person's
no, no,
time.
no. We remember, keep on. We had Kelvis wasn't able to make it from Kenya, so
Okay.
you were my filler, and it was obviously a great conversation because there's still lots of people who want to chat with you about like Christian Kohler says, I don't know why 120 volt is the solution. He's like, what are you guys talking about? It's all about total power, and you're right. Christian, it is all about total power, but there is the wiring within the house that is, $400 to $600 per device in order to get that new higher power to places where we electrify. And that cost can add up to being thousands of dollars just for rewiring, even without new power. So getting a stand in at 120 volt makes it much more cost effective to install the exact same compressor. It's a DC compressor. It doesn't care what voltage it is coming in. It already converts it to DC power. So we just need to make it easier, cheaper to install. Ram put it in his email address. Thank you, Ram. And Deborah was asking for the pre-cooling link. Deborah Little there. Thank you, Deborah, by the way. I've seen you been commenting here. It's wonderful to have you here. Deborah, I think, is our most stalwart attendee who I've been asking to come for years. And thank you, Deborah. So, but yes, here we are. And I think this is a perfect segue for our next presenter. So thank you, Ram.
Thank you. Thanks, Sean, and thanks for everyone for listening to me blather on for a long time.
Not at all. You are a global leader in electrification knowledge, and we bow down before the throne of knowledge. Thank you, Ram.